So right off the bat, this first one, I have to apologize. For some reason, the actual givens did not go in the statements column. All right, let's make sure we know what the correct givens are, that this is a rectangle and M's a midpoint. All right, sorry about that. That's on me. No excuses. So we are given that this is a rectangle, so we can use any of the rectangle properties. We're trying to figure out why ZMY is isosceles. All right, we've been down this road so many times. How are you going to know if it's isosceles or not? What are you going to show? What are you going to show on that middle triangle? If ZMY is going to be isosceles, what's got to happen? Oh, 7, talk to me. What's got to happen if this is going to be isosceles?
ZM has to be congruent to MY.
ZM, MY have to be equal. Only way we're going to do that probably is to get what equal first? Triangles equal on the outside. So here in your group, actually, as a class, let's just take care of this. M's a midpoint. Give me something true now. If M's the midpoint. 19. If M's the midpoint, something true. All righty. So everyone, that gives us a side. In the two triangles, we're trying to prove congruent, so we can get the sides congruent, so we can get an isosceles triangle. Definition of a midpoint. Next up, you and your group use the fact that this is a rectangle to get another property, but don't write anything down, just discuss it. Go, 30 seconds. Don't write anything down. Using your knowledge of a rectangle, what else is true?
So we have to say that they're right angles first. Then we
Okay, here we go. 8. Give me something that's true here. All right, I got WZ congruent to XY. Don't forget, even though it says rectangle, it's also a parallelogram. All right, Charlotte mentioned parallelogram implies. You can also do rectangle implies. It's also a property of a rectangle. Your choice. All right, your choice. I'll do rectangle implies opposite sides congruent, but if you add parallelogram in there, it's still correct. A rectangle is a parallelogram. All right, good. There's one more property of a rectangle I should be using here. That will give me another pair of sides or angles. I don't know if you guys discussed this in your group. 14, what else could I use the fact that this is a rectangle? Somebody have 14? Have been taken 14? Okay. That just got awkward quick. 16. Okay, listen, good news. Good news. Yes, they are right angles. But because it's a rectangle, aren't all angles congruent? So you do not have to go through that two-step process anymore of saying they're right angles or they're congruent, because the definition of a rectangle is all angles congruent. So I can go right to saying angle W congruent to angle X. And my reason? Nothing about right angles. Rectangle implies all angles congruent. That's nice, huh? But only if it's a rectangle. Paul?
You say definition of rectangle?
No. Jonah?
Can you say in a rectangle all angles are congruent?
Sure. You got want to add in more words than mine? All right, that's fine too. We all good? All right, rectangle only, I can do that. Don't have to mention that they're right and they're congruent. And then finally, I think we got enough info, right? Oh, triangle MWZ is congruent to triangle MWZ MXY. Oh, you're not done yet, though. You're not done yet. Why? Reason? 7, reason? side, angle, side. And then here we go. That's, you said prove the triangle's congruent, so I can get MZ congruent to MY. Reason here? Why are those two now equal? Oh, 6. Why are those equal? Yeah, I just proved triangles, so that means all the parts are equal now. And then finally, I think ZMY is an isosceles triangle now. Anybody got a good reason why it's isosceles? If you're going to tell me in a triangle congruent sides are across from congruent angles, that doesn't say it's isosceles. Paul?
Two congruent sides implies isosceles triangle.
Whew! We're flying by, huh? Go too fast, or you good? All right. All right, I'm not going to do the next one because that's a new one, and I want to save all those for the end. So go to the rhombus one, number 3, please. Go to number 3. I want to do all the new ones together. So I'm going to skip around, make sure we do the traditional statements and reasons ones first. Oh, now it's a rhombus. Now given a rhombus. And you guys have F. Ooh, look at those angles. FAB congruent to DCB. I'm trying to prove FE congruent to DE. That's not going to happen unless what? The triangles are congruent. Like, can we just get this out of the way before I let you work in your group? The vertical angles are congruent. Let's just get that out of the way. Angle FEA congruent to angle DEC. Vertical angles are congruent. That has nothing to do with the rhombus. Now I'm going to turn it over to you and your group. Using rhombus properties, can you find any more sides and angles? Talk it through. We'll get back in a second here. Go ahead.
So I think subtraction is say that
Use rhombus properties to get a couple more sides and angles.
You get this angle.
Know your properties. Know your properties.
Not equal, right?
Yeah.
Like angle ECB. And then use rhombus.
So we can throw rhombus also.
Yeah.
It's the same.
I think you said rhombus.
Rhombus isn't purpose. Well, you could say rhombus.
So,
Yeah.
feel like I know what the
Oh, vertical.
Yeah.
it's gonna be.
Then you can say EAB.
Remember that they buy.
Yeah.
Step 3, it says AE is equal to EC. And all sides.
Oh, yeah. Okay.
All right, let's talk. What else you have for me here in this proof? What else you have for me? 15. What else you have for me here?
You can say that side EA is congruent side EC.
Correct. And that would be rhombus. Can't use parallelogram here because that's not a parallelogram property we're using, right? Rhombus implies all sides equal or congruent. Good work, good work. So I got a pair of angles. I got a pair of sides. Need one more pair. And we haven't even sniffed the givens yet, have we? We haven't even mentioned the fact why they gave me FAB congruent to angle DCB. Hopefully we will now. Another rhombus property we could possibly use for angle A congruent to angle C. Griff, I'm just going to ask, be more specific. Because when you say angle A, I'm looking at 3 different angle A's here, right? There you go. Better. Angle EAB congruent to angle ECB. Everyone see what those are? Opposite angles. Right, those are opposite. I'm running out of arc marks here. You could say rhombus. You could also say parallelogram. It's a property of both. Your choice. Rhombus implies opposite sides, opposite angles, excuse me, congruent. What are you doing with those? Griff's correct, but I can't use, they're not in my triangle. What am I trying to do here with those angles and the given angles? What am I trying to work here? One, the given angles and the ones that Griff just gave me that the opposite angles are congruent. What am I doing with those to try to get angles in my actual triangles? Okay, here we go. Angle FAB minus angle EAB is equal to DCB minus ECB. Subtraction. And then can you guys take this proof from here? Substitute in the angles in the triangle. The last thing I'm just going to ask is why are they congruent? So this would be angle FAE congruent to DCE. Substitution. All right. Why are the triangles congruent before I say CPCTC? 3. Why are these triangles congruent? Angle, side, angle. Perfect. And then CPCTC to end this. Go ahead, finish it up. I'll give you time here. Go ahead, finish your proof up. Any questions? Anything at all? Going? Go to number 4. Go to the next one. All right, here we go. A new type of proof where your diagram is going to be on the graph now. No givens. Well, actually, the given is your coordinates. All right, those are your givens, your coordinates, and now your diagram is on the graph. So go ahead and graph that quadrilateral. And we're going to have to talk, a lot of talk. This will not be a statements reasons anymore when I do it on the graph. It will not be a statements of reasons. Okay, so let's first, we have a traditional proof, statements reasons. Last unit we talked about an indirect proof, right? This one in here, when I graph it, my diagram is on the graph. This is what we refer to as a coordinate proof. This is a coordinate proof, everyone. It's going to be done a heck of a lot differently than my statements and reasons. Because this is actually going to involve some algebra. Okay, we're going to introduce algebra into our proofs. We have to show it's a rhombus. It is a rhombus. It is. You just got to show me why it is. All right, show me why it is. What's the main property you guys know about a rhombus? Paul, go ahead.
All sides congruent.
All sides congruent. Show me this quadrilateral has all sides congruent. That's method number 1 up there of how to show a quadrilateral as a rhombus, and that's probably where we're going to stick to. Just show it has all 4 sides equal. Everything we've gone over this year, how do you think I'm going to accomplish that? Show all 4 sides are equal. It's on a graph now. You know the coordinates of those points. How am I going to show all 4 sides are equal? Tammy?
Distance formula.
Hello, we remember distance formula, correct? All right, yes. These proofs will now be using distance, slope, and midpoint. All right, to show the figure is what's being asked. So this is asked to show it's a rhombus for me. All right, you got it. So instead of statements, reasons, I'm going to organize this neatly. So step 1, use the formula you want. How are we going to show again all 4 sides are equal? Using what formula? Distance. Anybody remember the distance formula? Big square root. Go ahead, Paul. Think you got it?
Yeah. X2 minus X1 squared plus same thing.
There's your distance formula. Now let's go ahead and find the distance of in step 1. Let's go ahead and find the distance of all 4 sides. And if we're doing it right, what should happen? All 4 should be equal. If something is not equal, that means one of 2 things: user error, or you graphed one of the points wrong. All right, this is what's so great about these proofs. You know all the distances should be equal to each other. So if you don't get one that equals the other 3, either I need to go back and check my work or make sure I graphed one of these points incorrectly or not. What side do you want to start with? Who cares? They're all the same. Any side? AB, you got it, Brendan. AB, here we go. AB is equal to, let's plug it in. X coordinates, 5 minus 2, all squared, plus negative 2 minus 2, all squared. You can now that you've shown me that, you can go ahead and just, 5 minus 2 and then square it in your head. That's up to you. I should get 9 out here. And then negative 4 squared, I should get 16. Keep trucking. Here we go. Keep trucking. AB equals square root of 25, which is equal to what? 5. All right. So if I did this right, the other should come out to be 5. All right. Next up, what do you want? And all this is going to be in step 1, just showing the distances of all 4 sides. It's not a hard. What do you want? AB. We already did AB. AD. Okay, here we go. AD. Uh, 6 minus 2 squared plus 5 minus 2 squared. Oh, we're getting, yeah, look at this. What do we get? 9 again? Nope, sorry. What do we get here? 16 first here. Plus 9 here next. Oh, yeah, there it is. $25. 5. All good? Think you can do the other 2 sides on your own now. Go ahead. DC and CB. You know it's going to be 5, so if we don't get 5, something happened. Everyone all right with fives? Getting fives out for everything? Fives, fives. All right, now let's continue this proof. That was step one, just showing me your formula. Now, here we go, step two. Your second step should always be, what did you just learn from step one? You didn't learn it was a rhombus yet. What did you just learn by doing the distances of all four sides? Okay, so write it out. AD is congruent to AB, congruent to DC, congruent to CB. That's what we just learned. All four are congruent. And just like your proofs, your traditional proofs, you got to tell me how you know that. All four are congruent because, what do you got? How do I know all four are congruent? And I'm going to go back to my numbers. I get responses a little quicker there. 19. How do I know all four sides are equal? And what did it say? Because distances, you did the formula, right? Distances are what? Are the same or equal? Yeah. Distances are equal. So I did the distances of all sides, said they were equal. What's ABCD now? If all four sides are equal, ABCD is going to be a rhombus. There we go. So step 3, ABCD is a rhombus. And yes, can't just leave it like that. Why? Tell me why it's a rhombus. Based on the work you just did, why is ABCD a rhombus? Because 13.
Would it be the same as 2? All distances are.
No, I don't want to hear about the distances. How do I know, based on everything I've done, how do I know this? All sides congruent. There it is. There's a coordinate proof. I show you formulas that lead to a conclusion that lead to my figure. Now, hey, this is probably the easiest way to prove a rhombus, but I also want to let you guys know there's 3 other ways I could do it. I could show it's a parallelogram and then do 2 sides instead of all 4 congruent. I could do a parallelogram first and then show the diagonals are perpendicular. All right, but I think this is probably going to be where we'll stay to prove a rhombus. Questions? This is going through the entire unit now. This is just not a one-day thing. All right, I know it's very, very awkward because you don't know what to write. How can I want to make sure I say this correctly. You can never write too much. Okay? You can never write too much on these proofs, right? The more, the better. Rhombus was easy. Unfortunately, we got a little bit more work to do. Go back to number 2 for a rectangle. We got to show a little bit more work for a rectangle. Okay, we got them graphed, ready to go. All right, now, rhombus was easy, just show all four sides congruent. Rectangle, we got to put in a little bit more work. And as you guys see, there's three different ways you could prove this is a rectangle. We could say it's a parallelogram first with a right angle, a parallelogram with congruent diagonals, or just it's got four right angles and that's it. Also, if you guys take a look, if you go in your packet real deep, can you go to page, it looks like 54? The packet ends on page 52, but then there's no numbers following that, unfortunately. But I think if it would be page numbers on the bottom, it would be 54 and 55. 53, 54, 55, yep. This is nice that I listed this out for you, but if you want a visual of how to prove these figures, it's right here. All right, so you guys see, everyone see prove rectangle? All right, if you see prove rectangle, see the first one, you could show four right angles. Second one, parallelogram with a right angle. Third one, parallelogram with congruent diagonals. Okay, and if you're wondering how to do a parallelogram, it's on the previous page. Okay, so here's what I'm going to choose for us here. We're going to show it's a parallelogram first, prove a parallelogram, and then say that parallelogram's got a right angle. Okay, that's how we're going to show this as a rectangle. Job number one, let's show it's a parallelogram. We have so many choices. All right, so many choices to show it's a parallelogram. You guys tell me, how could I show a parallelogram? We came up with 5 reasons the other day. Caitlin, just one. We could show the opposite sides are congruent. What formula would I need for that? Distance. Now look, I get it. Some of you may not be fans of the distance formula. That's fine. We have other options. How else could I show a figure's a parallelogram? Caitlin says, hey, show opposite sides congruent. What else could I do? Charlotte. All right. I could show the opposite sides are parallel. How would I do that? What formula would I need for that? To show this side, the opposite sides are parallel. To show the opposite sides are parallel, what formula would I need here? We've done it this year. We have showing QRS and QP are parallel. I would need what formula? Eva? Slope formula, correct. So if I'm going to show opposite sides are parallel, I need slope. What else could I show here? What else could I show that makes it into a parallelogram? Keep coming here. Come on. Give me some properties. Jonathan. Okay, yes, on a normal proof. In a proof on the graph, it's kind of hard to tell what formula would I need to show the angles are equal, right? You see where I'm going there? It's hard to tell on a graph to prove that the angles are equal. All right, so I'm going to leave that one off for now. What else could I have done? Keep going. Properties. Paul.
One opposite side parallel.
That's for the hardcores out here. Because what formulas am I going to need for this one? Yeah, distance and slope. So if you like torture, go ahead, use that one. And there is one other way I could prove the parallelogram. We're forgetting here. Serena? Correct. And the question would be, how do I prove that two diagonals bisect each other? Show they have the same midpoint. So you need the midpoint formula here. Midpoint. All right. So let's make a class decision right now. Which way are we going to do for this one? Because the first thing we need to do before we prove it a rectangle is prove it a parallelogram. Which method would you like? Which method are we going to do? The slope, the distances, one of each, or midpoint? Okay, how about we just say, I should have just, instead of majority here. Who want distances? Distances? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Slopes in the house. 1, 2, 3, 4, 5, 6, 7, 8. Oh, perfect. Perfect. Distance and slope. Claire.
Wait, I meant to vote for number 4.
Midpoints. 1, 2, 3, and Claire 4. All right, great. So it's 8, 8. So I'm going to break the tie. We're going slope. All right, just because you know how to do distances already, I do have to reintroduce slope. That's why we're doing it. That's why I chose that way. So we're going to show opposite sides are parallel. Opposite sides are parallel by using slope. Letter for slope again. Because I don't have to write, I don't want to write out slope every time. M, thank you, Meg. So let's first find the slope of QR, everyone. Slope of QR. I know it's changing y over change in x, but I'm not going to plug in the coordinates. I'd rather, because it's graph, I'm going to use rise over run instead. All right, I'm going to use rise over run to find the slope of QR. So can everyone in their group right now, up and over, how many? Up 2 over 3, but it's not 2/3, it's, thank you, negative 2/3, right? Because you're going downhill. Negative 2/3. All good? All right, go ahead in your group. Let's find the slope of PS. Slope of PS, up and over how many? And shockingly, what did it come out to be? Negative 2/3, it should, because I'm trying to get opposite sides parallel. All right, next up, let's do slope of QP, everyone. Slope of QP. Go ahead, up and over how many in your group? Rise over run. QP, what are you guys getting? 6 over? Positive or negative? Positive. If you want to reduce, it's fine. It's not required. But if you want to reduce that to 3/2, feel free. And finally, how about the slope of SR? Up and over 6 over 4 again. Are we all getting that? Yes? So we're okay with these values. Slope, rise over run. All right, good job you finding the slope. What did you just learn by using the slope now? You didn't learn it was a parallelogram yet. What did you just learn by using the slope? Paul?
QR and PS are parallel.
Okay, ready? QR is parallel to PS. And I think we learned more than that, right? QP is parallel to SR. All right, give me the Y. Because, how do we know they're parallel? Look at the work we just did. 3. Eva. Because slopes are equal.
Yeah.
Done. That's all I need. I don't need anything more because slopes are equal. What you said was fine too. Let's just narrow it down a little bit, right? All right, hey. Good job. Good job. You don't need to do this, but good job. What can you tell me in step 3 now? What's true about my diagram? I got the opposite sides parallel. What's true about it now? This is what? 2? Not yet, Matt. Not yet, it's not. Just because I have opposite sides parallel doesn't make it a rectangle. It definitely makes it a what, though? There we go. PQRS is a parallel. It's not a rectangle yet. I don't have enough information, but it's definitely a parallelogram. PQRS is a parallelogram. How'd you know that, Matt?
Because opposite sides are parallel.
Done. Opposite sides parallel. Not a rectangle, though. It's a parallelogram. Now, what do I have to add on to it? I need to figure out how I can show one of those angles as a right angle. A parallelogram with a right angle makes a rectangle. Oh boy. How do I show there's a right angle at Q, R, S, or P? I don't need to do all four, just one. How are right angles formed? With perpendicular lines, right? Going back to good old slope. Anybody remember the slope between two lines that are perpendicular? Negative reciprocal. Yep, I say opposite reciprocal, negative reciprocals. All right. Two lines that have slopes that are negative reciprocals are perpendicular. Oh, I think we did the work already up here. Anybody see anything that could be a negative reciprocal? Using these numbers here, using my slopes, give me two lines that are perpendicular because their slopes are negative reciprocals. Go ahead, give me two lines up here that have negative reciprocals as their slopes. Oh, 21. Okay, let's see. QR is negative 2/3, RS 3/2. Yep. So everyone ready? QR perpendicular to RS. I could have used other pairs too, right? I could have used other pairs. Perpendicular because, how do we know? Tammy, how do we know?
Slopes are negative.
Thank you. Slopes are negative reciprocals. And then pretend this is statements reasons now. You know the lines are perpendicular. What happens usually next? If I know two lines are perpendicular, what do I usually say next? Where though? I can't say any right angle here. I got to go QR and RS form a right angle where? Where's my right angle if I pick QR and RS? There you go. Okay. Angle R is a right angle because yeah, I don't know any different. Perpendicular lines form right angles. And now put step 3 and step 5 together. It's a parallelogram with a right angle. That equals rectangle. PQRS is a rectangle. Oh, shoot. Spell. Yeah, I know, that's garbage. Why? Why is it a rectangle? Not because it has a right angle. I could show you a lot of quadrilaterals that have one right angle, but it's not a rectangle. What made this one into a rectangle for us? What made it into a rectangle? Jonah, go ahead.
It was a parallel.
Stop right there because a parallelogram. Keep going. Keep talking now.
With a right angle.
Darn right. Go ahead. With a right angle is a rectangle. Yes. Go to your homework real quick for me. I just want to make sure there's no confusion tonight because you do have a couple of these coordinate proofs at the end. So if you go to number 3 real quick. Okay, number 3. It says prove it's a parallelogram, so we can do that, no problem. We did that today. Prove it's a parallelogram, but not a rhombus. I just want to make sure we're good. This isn't indirect or anything. Okay, you're going to prove it's a parallelogram. How can you show it's not a rhombus? What do you think? It's not. Don't start thinking indirect proofs or anything like that. It's already a parallelogram, but how can you show, hey, wait, that thing's not a rhombus, Sarita?
You can say the two sides are not congruent.
Done. Do I need to show all 4 sides? Nope, just 2 sides aren't equal. It's not a rhombus. Good job. All right, so just want to make sure we're good there. Get after it tonight. You can start it now if you'd like on those proofs.